I'll share the screen. Okay, we are here with playing with numbers. Can you all see the screen now?
Yes, ma'am.
Okay, now the first concept is factors and multiples. Right? What are factors? Factor is some number which is exactly divisible by a bigger number.
Yes,
Okay. Like suppose the dividend is one number, divisor is one number. So divisor is exactly divisible by dividend. So that means we call it a factor. Yes, it's written here. A factor of a number is an exact divisor of that number. Okay. When you divide, you get the remainder 0. So that is dividing it exactly when no remainder is left. Okay, now coming to factors part. Let's randomly just take some examples or some question from the exercise part. Write all the factors of the following numbers. Please write the factors of 23. Find the factors of, okay, leave 23. 23 is a prime number. Okay, write factors of 21. 21.
1,
Yes.
3,
Yeah.
7,
Hmm.
and 21.
Okay.
Yes.
1, 3, 7, and 21. Okay, make factors of 36. Charvik,
One.
let Charvik say.
1, 2, 3.
Not able to hear, please write in the chat box. Write the factors of 36 in the chat box.
1, 2, 3.
1,
2.
3.
No, that's 2, 3.
Please write it in the chat box. I'm not able to hear Richard.
I once asked him to remove his earphones and try.
But then how will he listen to me without earphones? Write in the chat box, Charvik. Okay, 1, 2, 3, 4, 6. Okay, that's right.
12 also.
There are more 12 also. Yes, 12 is here. Okay. And 36 itself also. Okay. 12, 18. Great. Okay.
No, can you
Yes.
hear?
Okay, now coming to prime and composite numbers. So children, prime numbers are those which have factors only one and the number itself. Okay, it has no other factor. Okay, just one and the number itself. Like suppose 2, 3, 5, 7, 11, 13. These sort of numbers are prime numbers. So you should learn all the prime numbers from 1 to between 1 to 100. You should know all the prime numbers. And I had given you this homework also when we were doing this chapter, right? So now for exams, you must learn all the prime numbers between 1 to 100. Okay. Okay, now composite numbers are those numbers which are not prime actually. So what is the speciality of these composite numbers? Composite numbers have factors more than one and the number itself. Okay, it has more number of factors, right? Suppose if you take number 12, so 12 has so many factors apart from 1 and 12. One second. Let's suppose if I have taken a number 12, So 12 has factors other than, apart from 1 and 12, it has more factors. It has 2 as factor, it has 3 as factor, it has 4 as factor, it has 6 factor. Then what else? And 12 then. Okay. So it has so many factors. So, but if we talk about prime numbers has only one factor and the number itself. But if you talk about composite numbers, it has more factors than one and itself. Okay.
Yes, ma'am.
Okay. Now these are the numbers, all the numbers from 1 to 100. You must, these circled numbers are all prime numbers. So you must learn these numbers. Okay. This is what I'm telling you to learn. Learn all these prime numbers between 1 and 100. Okay. Let's see, take some numbers from here, take questions here. Okay, let's see this question number 3. Rishit, please read this question.
Ma'am, third one.
Yes, third one.
Yes, ma'am. The numbers 13 and 31 are prime numbers. Both these numbers have same digits, 1 and 3. Find such pairs of prime numbers up to 100.
So see, 1 and 3 are they exactly opposite of each other, is it?
Yes, ma'am.
So you have to find such more pairs up to 100. Okay, so that means suppose I'll give you example. 17 is prime number, 71 you can take. Tell me some more.
Yes, ma'am.
Tell me some more.
One second. Ma'am, 19 and 91.
91 is not prime basic. It comes in the table of 13 and table
Yes,
of
ma'am. Yes, ma'am. Yes, ma'am. I forgot.
so you can see here 37 and 73, 79
Yes.
and 97, 17 and 71 we have already discussed. This is given. Okay.
Ma'am?
Yes.
Nothing, ma'am. Nothing.
Okay. 37, 73 is another pair. 79 and 97 is another pair. Okay. Okay,
Yes.
let's see this now. Question number 6. Charvik, read question number 6.
Yes, sir. Express the following as the sum of two odd prime.
We have to express these numbers as the sum of two odd primes. Okay, two odd prime numbers. Let's suppose, although we have done here, we have written here, but still it's a revision now. Now 47, 44 can be written as 7 plus 37. 37
Yes,
is also prime, 7 is also prime.
Yes, ma'am. And
37
they both are odd.
Both are odd also. Okay, all prime numbers are odd, only except 2. 2 is the only even prime number. Okay. Now 36 can be written as 31
31
and
plus 1. It's
okay,
31 plus
plus
5.
so it's not necessary that you also should make only this pair. You can use any other prime numbers also to
Yes,
make
sir.
this combination. Now 24 can be written as 19 plus 5. 18 can be written as 11 plus 7.
Yes,
Okay.
ma'am. 17 plus 7 also.
Yes. And it can be written as 13 plus 5 also.
Yes, ma'am.
Right? Okay. And 7 consecutive composite numbers less than 100 so that there is no prime number between them. Okay, so you write 7 consecutive prime numbers where no prime number should come in between. Okay, this should mean continuity. 7 prime numbers. If we take from 90 onwards, 90, 91, 92, 93, 90, 91, 92, 93, 94, 95, 96. Is there any prime number coming in between this?
No, ma'am.
No, 97th is prime. So
Yes,
we have 7 and 90, 91, 92, 93. Just put commas here. 94, 95, 96, 97. right? And if you see that table there, which I had shown you here also you can see from 90 to 96, we have taken consecutive 7 numbers, no, where no prime number is there. So you
Yes.
can find more this sequence also. Okay, where all numbers should be in line. So if we take it like this, these are 5. Wherever you have 7 consecutive numbers, you can just pick out that. Okay, so I found only 70 to 90 to 96. Here there are 5, here there are 5. So most of the places there are 5, there are 6, but this is the one where we have 7 numbers. 1, 2, 3, 4, 5, 6, 7. Right?
Yes, ma'am.
Okay. Now, see question number 10. Express each of the following numbers as a sum of 3 odd primes. So 3 odd primes. Here we were doing with 2 odd primes, no? The other question, this one we were doing with 2 odd primes. Now here we have to do with 3 odd primes. Okay, now 21. 21 can be written as 3 plus 7 plus 11. So 3 plus 7 is 10, 10 plus 11 is 21. So this is one combination of 3 odd prime numbers. Okay. Same thing you can make for 31 also. What can you write for 31? This is here, it's written here 23 plus 3 plus 5. You can make other combinations also. Okay, not necessary that ma'am has written this, so
Yes,
you
ma'am.
have to take this only. You can make your own. But keep in mind that the numbers taken should be odd primes. It should be odd also, it should be prime also. Okay, and combination of 3. Then 53 can be written as like this. You can see here 13 plus 7 is, okay, this is for 31 only. 13 plus 7 is 21, 21 plus 11 is 31. This is 31 only, 31 only. Just check out this. Okay, so these are some different combinations here. 47 plus 11 is 58, 58 plus 3 is 61. So this is for
Yes.
61. Okay,
Or is 50,
44 plus 17. That's again 61. This is another combination for 61, right?
so we can do like this.
So this is 23 plus 11 is 34. 34 plus 19 is how much? 34 plus 19? 30, 53. So this is for 53. Combination for 53 is this. Okay, 23 plus 11 plus 90. So same thing, you can find out different combinations. Okay, but only thing to keep in mind is it should be odd, it should be prime. Okay, all prime numbers are odd only, meaning except 2. So no need to worry about odd, just take prime numbers. Okay,
Yes.
but don't take 2. Okay, let's move ahead. Now testing the divisibility of numbers. Let's check the divisibility of numbers here. Okay, now what is that divisibility of, let's do it, divisibility of 2 first. Divisibility of 2 is all numbers should be even.
Even.
Divisibility of 3 is sum of the
Sum of,
digits.
yes,
Sum of
should
the
be
digits.
it should be divisible by 3.
Sum of the digits should be divisible by 3. For divisibility by 4 is when the last two digits are divisible by 4. That means the whole of the number is
Yes.
divisible by 4. To check the divisibility by 5, the
The
units
number
place,
must be ending with 0 or 5.
yes, the units place number should be 0 or 5. Okay. Divisibility by 6 is either the number
Should be
should be
divisible by
divisible
2
by
and
2 or divisible by 3 also. Okay, if the number is divisible by 2 and 3, that means the number is divisible by 6 also. Okay, and 7 divisibility is not there in this, but still I had told you something about that. Let me check, I'll see afterwards. Okay, now divisibility by 8. It is when the last three digits, okay, the last three digits are divisible by 8. That means the whole big number is divisible by 8. Alright, divisibility by 9 means this is the sum of all the digits, like same way. Here, the divisibility of 3 and 9 is same, sum of digits should be divisible by 8. Divisibility by 10 is last digit, the units place digit should be 0. Okay. Divisibility by 11 was sum of the digits at the odd places. Okay. And sum of the digits at the even places. Okay. When you take their difference, it should be either 0 or 11. Is that?
Yes, ma'am.
You remember? Digits in the odd place and digits in the even place. When you take their difference, this is sum of the digits in the odd place and sum of the digits in the even place.
Ma'am, I remembered, but I was a little, so that's why I didn't answer.
Okay, no problem. So when you take their difference, either it should be 0. If it is 0, then the number is divisible by 11. And if it is 11, then also the number is divisible by 11. But if it is anything else other than 0 and 11, then it is not divisible by 11. Okay?
Yes, ma'am.
What is this? Okay, this is, we were doing the divisibility by 0 and 11 by 11. Okay, now this is based on your divisibility. Let's do some questions from here also. And then we'll move to prime factorization. Okay. Write first 3 common multiples. So what are multiples? Suppose I tell you to make the multiples, five multiples of 3. Charvik, tell me first 5 multiples of 3.
How can you please repeat?
Huh?
How can you repeat?
First 5 multiples of 3.
Okay, ma'am. So it will be yeah.
Just the table of 3.
Okay.
Okay.
Now,
3 ones is 3, only 3
3
twos is 6.
3, 6,
3,
9, 12, 15,
12, 15 and one more.
and 8.
Okay, these are the first 5 multiples of this. So whatever comes in the table of that number is the multiple of 3. Okay, and 3 is a
Yes, ma'am.
factor of all its multiples.
Yes,
Okay,
Yes, ma'am.
a number is divisible by both 5 and 12. By which other number will that number be always divisible? Any number, some number is divisible by 5 and 12. That means 5 and 12 are the factors of that number. Is it?
Yes,
So
ma'am.
we multiply 5 and 12, we will get 60. So that means
60.
this number is 60.
60.
Okay.
Yes, ma'am.
Okay, a number is divisible by 12. By what other numbers will that number be divisible? Okay, any number, it's saying it is divisible by 12. Now, what are other numbers which will also be divisible? Will that number be divisible? So, all other factors of 12 will be all divisible by 12. Is it? So all the factors of 12 will also be divisible with that number. No? If 12 is divisible, so all the factors of 12 will also be divisible. Okay.
Yes.
Okay, now writing common factors. Common factors, you know, if we have numbers 4, 8, and 12, and if you find all the factors of 4, 8, and 12, so what are the factors that are common? We just take the factors of 4, 4. What are the factors of 4? 1, 2, and 4. Factors of 8 are, what are the factors of 8?
1, 2, 4, 8.
4, 8. And factors of 12 are 2, 1,
1,
3, 1, 2, 3, 4,
4, 6,
6,
12.
12. Okay, these are the factors. Now, what are the common factors? See, 2 is common here, here, or here. 4 is here, here, here. Okay, so that means 2 and 4 are the common factors. Okay, so these are the common factors. And if we ask, if somebody asks, these are the common factors. If somebody asks you which is the highest common factor, so highest of the two number is the highest common factor. Yeah? Among 2 and 4, which is the highest number?
4.
So that becomes the highest common factor. Okay. So we'll
Yes, ma'am.
study about highest common factor and lowest common multiple also. But before that, we come
LCM
to
and
prime.
HCM.
We come to prime factorization. Okay. Do you know how to find the prime factors if I give you some numbers? Hmm? Okay. Please write down the prime factors of this question number 5. Write all the prime factors of 1729. Please find the factors, prime factors of 1729. Done?
Ma'am, we need to do short division method, right?
See here, this grid form. See, look here, it's done here. 1729. Okay. This is called grid. Make a grid like this, no? Tabular column. So we we divide it by 7. So we have 7 2s are 14 and 3 is left. 3 7 4 is 28. Okay. So 247 we get. Then again we see that it is divisible by 13. So 13 into 19 gives me this number. Okay, so we'll have to check it. Where, suppose, how do I get 7 in the units place? What will I divide 3 with so that I get 7 in the units place? So somewhere I will think of number 9. Okay, if I multiply with 9, I will get 7 in the units place, but I will not get the other number here. So I will just increase the number. Okay, then okay, then I'll reach at number 99. Okay. All right.
Yes, ma'am.
This is how you look for numbers. That what will I divide it with so that I get units place this. So that will give you a hint. And if one number does not work, then go to a next higher number, then go to a next higher number. And gradually you will reach the number which is actually dividing. Okay, then 19 is a prime number, so 19 into 1. So factors for this are 7, 13, and 19. Okay, now I tell you find the factors of, say, number 63. How will you find the prime factors? For whenever you are given a question to find prime factors, you always make like this grid. Okay, so you can see here this number will go with 3. 3 2s are 3 1s. So this is just a small example I've taken just to show you. Whenever you are asked to find prime factors, you must do it like this and must take those numbers which are prime numbers. So always start with small prime numbers, 2, 3, 5, whichever number is divisible by goes with this. Okay. So 3 sevens are and 7 ones are, right? So what are the prime factors of these 3, 3 into 7? Okay. Right?
Yes, ma'am.
Okay, now coming to highest common factor. Now, highest common factors, we find the common factors, and among the common factors, the highest one is highest common factor.
Highest common factor.
Okay, let's take for this 34 and 102. So 34 and 102. I write the numbers like this. I'm taking it together. Okay. Sometimes what happens, children do like this. They take for one, they take for other one. Okay. So instead of that, if you can do, you must take it together. Okay, so I can see both are even numbers. So I have to find factors, highest common factor. So I'll start with the least number, that is 2. Both are even numbers. So I'll get 17 here. 2 multiplied by 17 gives me 34. And 2 5s is 10. 2 1s is 2. This is 51. Now I can see that both these numbers can go with number 17. What number will give me 1 in the units place if I multiply this with 17? Because 17 into 1 is 17. So I can see 3. I can imagine of 3. 7 3 is 21. I will get 1 in the units place. This will prompt me to think if I can multiply with 3. Now 3 1s are plus 2 is 51. So it is 3 here. So which are the common factors here? 2 and 17. Is it?
Yes, ma'am. 2 and 17.
2 and 17 are the common factors, no? And the highest common factor will be what? If I
17.
multiply both. If I multiply both, I will get 34.
Yes, sir.
Is it? So if I multiply 34 means, if I multiply this whole thing like this with 34, 34 ones are and 34 threes are. Okay, not threes are. This will be whatever it is when it goes with 2. Okay, 34 is the highest common factor or whatever number comes here. Okay, right?
Yes, ma'am. Clear.
We'll see 3 only. 3 4 is 12. 9 and 1 10. We get 100. So this is 3. Okay, so 34 is the highest common factor. But we could not think of 34 first, no? Because we don't know the table of 34. So we tried with small numbers. Okay, and moreover 34 is not a prime number. Okay, we are finding the prime factor with, but we are finding HCF. For HCF it can be any number. This is not prime factorization, this is HCF.
Yes, ma'am.
But if we do with prime factors, it becomes easy for us. If we take small numbers, it becomes easy for us because we all know the small tables. Is it?
Yes, ma'am.
Big tables we don't know, no? And we don't get
Yes,
into
ma'am. They are hard to remember.
and even if you get into that, you might make mistakes. So do with small numbers. Okay. So let's do some more questions on HCF. So do for this, you find out 27 and 63. Please find the HCF of this. 27 and 63. Yes, Soumya?
Ma'am, is it 154?
I don't know, beta. Just check. I'll check. Okay, these numbers can go with 3 9s. I'll also have to check. Okay. So this can again go with 3 9s or 3 7s now. So this is the highest common factor, no? 3 and 3. Because now I cannot take with any common number. Is it? In the end, I have 3 and 7. So my highest common factor is coming out to be 3 and 3. That number which divides both these numbers together. So that's 3 multiplied by 3, that is 9. So highest common factor
Ma'am,
is...
ma'am, we can multiply 3 into 3 into 3 into 7, right? Because
that becomes the LCM then. If you multiply all this, no? This we take it as LCM. This becomes the LCM. But if you take only this, because this number is common for these two. This number is common for these two. But if if I take 3 alone here, it will not be common for both. If I take alone 7, it will not be common for both. Is it? So the common
Yes.
for both is the highest common. Okay, this is HCF. But if I multiply this whole and this side also, this becomes the LCM. Right?
Yes.
Okay, now coming to LCM. Okay, these are the statement sums now. Okay, let's do some statement sums. Okay, we'll do this one. Soumya, read question number 3. Where is Soumya? Soumya, read question number 3.
The length, breadth, and height of a room are 125 centimeter, 375 centimeter, and 450 centimeter respectively. Find the longest tape which can measure the three dimensions of the room exactly.
So the length, breadth, and height of the room are given. Okay, 825, 675, and 450. These length, breadth, and height are given. Find the longest tape which can measure the three dimensions of the room exactly. Now we have to find the longest tape which can take the measurement of these height, length, breadth, and height. Now, how do you know what to find here? Now, what will you find here? HCF or LCM? Yes? See, children?
HCF.
Look here, children. How do you get to know that where you have to find HCF and LCM? See the questions in which you have the words like maximum, highest,
Longest.
longest, such words. If you find such numbers, just a second. Hello.
Yes.
Okay. So children, wherever you have such numbers, no maximum, highest, longest, and such synonyms of these numbers. Okay. Okay. Synonyms you understand, no? With the
Yes,
similar
ma'am.
meaning.
The words should same.
Like maximum, highest, longest, biggest. So such if you have come across such kind of words in a question, so that prompts you to find the HCF. Prompts you. I'm not saying exactly. It prompts you to find the HCF. And now I'll tell you what's the meaning of prompts too also. Okay. But in suppose if you come across numbers like minimum, smallest, least, okay, smallest, least, or synonyms of these kind of numbers, then you find least common multiple, that is LCM. Are you getting?
Yes, ma'am.
Okay, now this also prompts you to take LCM. Now, what do you mean by prompts to? Prompting means, that means your first focus goes on finding the HCF in such, when you get such words. Your focus goes on finding the LCM when you come across such words. But the tricky part is that the language of the question. Okay. Sometimes the
Yes, ma'am.
question language, the English of the question is molded in such a way that uh, that the words are taken in such a way, you know, where you have to find the least and they mold the sentence in such a way that they get the maximum word inside. And what actually the meaning of the question is to find the LCM. Are you understanding?
Yes, ma'am.
So the tricky part is that when the language of the question. So first thing is that you must understand the language of the question. What is the question actually saying? Then focus on the words which are written there. Minimum है, maximum है, highest है, longest है, smallest है, least है, क्या चीज लिखी है, right? Okay.
Yes, ma'am.
So along with these words, you must go on the language of the question and understand the question well, right?
Yes, ma'am.
Now see in this question, the length, breadth and height are given respectively. Find the longest tape. Now it is saying find the
Longest.
longest word goes for HCF.
HCF.
Okay. Longest tape which can measure the 3 dimensions of the room exactly. So here I don't see any molding in the question. It is saying the longest tape which can measure the dimensions exactly. Exactly means leaving no remainder zero. No remainder means remainder 0. Okay, that means it is the HCF. If I find the HCF and I divide that number with that HCF number, I will get remainder 0. Is it?
Yes, ma'am.
Understood? I find
Yes,
the
ma'am.
HCF of these numbers. Okay, let me find the HCF of, please find the HCF of these numbers first. Please find the HCF. Two, 6, 22, 3, 6, 18, 3, 7, 21. 3 5s are 15, 3 2s are 6, 3 2s are 6, 3 5s are 15, 3 1s are 3 5s are 15 and 0. Again, I can check this with 5. 5 5s is 25, so 5 5s is 25, 5 4s is 20, 5 5s is 25, 5 3s are and 0. Again, I can do with 5, 5 11, 5 9s are 5 6 are. Now I don't have 11 is a prime number, so I don't have any common number which I can divide this with. So here I get the HCF as 3 into 5 into 5, right?
Yes, ma'am.
So that gives me 25
75.
to 3 is 75. So 75 is the HCF. That means
Yes, ma'am. I
if
also
we
got the
divide
same answer.
individually this number 875 with 75, I will get whatever number I divide, I get it here, I will get remainder 0. Okay. You can divide and check. Whatever you divide it with, you will get remainder 0. Okay.
Yes,
Okay.
ma'am.
And similarly, if you divide this individually, you will get remainder 0. If you divide this individually with 75, you will get remainder 0. Because the highest common factor is 75. So that means these numbers are exactly divisible by these, which leaves no remainder. So that means it is exactly measuring the dimensions, right?
Yes, ma'am.
Understood? I hope you have understood.
Yes, ma'am.
What about others? Only Rishit is saying yes, ma'am, yes, ma'am. And others are quiet. Why? Charvik,
Yes, ma'am.
Soumya,
Yes, ma'am. Yes, ma'am.
are you understanding? Okay,
Yes,
we'll
ma'am.
take some more example on LCM also. Take some LCM sum also. Okay. LCM वाला भी sum को लेते हैं ना, so that okay. Okay, let's take this one. Question number 6. Look here. Rishit, please read this question number 6.
Yes, ma'am. The traffic lights at 3 different road crossings change after every 48 seconds, 72 seconds, and 108 seconds respectively. If they change simultaneously at 7 a.m., at what time will they change simultaneously again?
So what do you understand in this question? The traffic lights at 3 different road crossing change after 48 seconds, 72 seconds, and 108 seconds at 3 different crossing points. Okay. Now, if they change simultaneously at 7 a.m. Now, by coincidentally, it's happening that they change at 7 a.m. Okay. At what time will they change simultaneously again? Now, when will that coincident will again happen? At what time? Are you
This
understanding the question?
Yes, ma'am. This question we got many times in exam and in class too. We practiced many times.
Okay.
So I remember the answer till now.
Okay. Okay. Then I must change the numbers and give you something else. Okay. But
Change
remember.
at 9 a.m. again.
Okay. So please look into the concept of this. So it's asking when will that coincident happen again? Once this coincident happened, what coincident happened? That all the lights
They
were
all changed at
changed
same
together.
time.
Okay. So this incident happened at 7 a.m. Now it's asking when will this coincidence happen again? Okay. So what will you do this? See, this coincident will happen again and again and again. Okay. After some time span. Okay. It has to go on. But you have to find the least time that it will happen first. After 7 a.m., when will it happen first? So of all the times, you have to find that least time when it will happen again. You understood?
Yes, ma'am. Ma'am, so for this we need to find the HCF.
HCF, see, this is the language of the question. When will they change simultaneously again? Now it will change again and again every time. एक बार 7 AM पे हुआ, दूसरी बार किसी और टाइम पे होगा, थर्ड टाइम किसी और टाइम पे होगा, फोर्थ टाइम किसी और टाइम पे होगा. But we don't want all this. We just want what is the next time it will happen again. The least time it will happen again. Maybe it is happening after 12 hours. Maybe it is happening after 18 hours. We don't know that. But the least time it will happen again. कम से कम टाइम में वो second time कब
Yes,
होगा? This is what. Are you understanding now?
yes, ma'am.
So least time means कम से कम time में when it will happen again. So that is we will find the LCM. Okay,
Okay, ma'am.
understood?
Yes,
So
ma'am.
please find. So 48 is here, 72 is here, 108 is here. Let's find out.
With 2.
Do with 2. All numbers can go. Others also please do. I won't answer from others also. It's only Rishit who is answering.
And today very less people join.
Because they actually most of the children have exams have started. No?
Yes, ma'am.
For me, from 5th it will start.
Okay, no problem.
When March is on 18th.
So until you have exams, you can keep practicing whenever you have class.
March is last exam for it. It's on 18th.
Okay, now, oh, sorry, this will not go with 2. I must take 3 here, 3, 4 sides here. Now this is 4, 6, and 9. Now,
Yes, ma'am.
okay, now this is no longer now HCF. So I'm just taking these numbers. 3, 2,
So 4 will be the same.
4 will be the same. 4, 2,
Then we can take 2.
we can take just 2, 1, 2. Okay.
All are the prime numbers.
So now what is our LCM? LCM, I said LCM will be multiplied all these numbers and then multiply all these numbers also. Okay. So this gives you the LCM. So that is 2, 2. How many times 2 I have? 1, 2, 3, 4. So 4 times 2. Right? 1, 2,
Yes, ma'am. Ma'am,
3, 4.
ma'am, when I first learned LCM, I thought like if there are 2 4s, we need to multiply 2 into 4.
When there are 2 4s.
No, there are 4 2s. So I thought instead of multiplying 2 4 times, we can directly multiply 2 into 4. But later I understand that it's wrong.
Okay. So, and then we have just 1. So 1 will not make any difference. Okay, so this is our LCM. 2, 4, 2 2s are 4, 4 and 4 is 16. 16 into 16, and then you have 3 3s are 9, 3s are 27. Just multiply this and what you get as your LCM. 27 into 16 is what? 6 7 is 42, 6 2 is 12, 12 plus 4 is 16, 1, 2, 2, this is 13, this is 4, 432. Okay, so that means after 432 seconds or minutes, what was the unit given there?
Ma'am, they gave AM.
No.
Seconds,
Seconds.
ma'am.
These are all in seconds. Okay, so this is after 432 seconds, the lights will change again. Now 432 seconds means how many minutes? So we will just divide it by 60 to convert it to minutes. So that will give you 6 7 is 42. Okay, then you have 12.
72.
That's coming to be 7 minutes and 60 seconds, right? Okay,
Yes, ma'am.
so 7 minutes and not 60 seconds. 60 seconds will be 8 minutes only.
Yes,
12
ma'am.
seconds, 7 minutes and 12 seconds, right? Okay,
Yes, ma'am.
so you understood this? So what
Yes.
prompted us to take the LCM? What prompted us to take the LCM? The language of the question.
Yes, ma'am.
Is it? It's saying what time it will after what time it will change simultaneously again. तो again तो बार बार होगा, एक बार होगा फिर से होगा फिर से होगा, after some time it will happen. ऐसे incidences आते ही रहेंगे. But what is the least time? That time we have to find out. The least time is when will it first change?
Because we have least in the meaning of the sentence, so we did the LCM.
Okay. So I'll give you some other question which is not from this but similar kind of. Okay, we'll do this first.
But we have less than.
We have less time, no problem. We can continue this next time also.
Yes.
Okay, find the least number which when divided by, I'm doing this question number 8. Least number, find the least number which when divided by 6, 15 and 18 leave remainder 5 in each case.
Ma'am, shall I say how to do?
Yes.
So first we need to find the LCM as there is least in the
Yes,
sentence.
it's least.
Yes,
Good.
so the LCM of 6, 15 and 18 and we need to add 5 to the LCM.
We have to add 5 to the LCM.
Yes, ma'am.
Okay, the least number which when divided by these numbers leaves remainder 5. Right. Okay.
Yes.
So when you divide and add this 5 to the remainder, you will get your answer.
Yes.
Okay, now I'll give you one question. I'll write here on one side. Okay. Okay, this is similar like that of traffic lights on. Okay.
Okay.
Now it's saying the question is, I'll give you some questions for homework also, although you have subjective test also, but if you want some questions on HCF and LCM, I'll give you. Okay, just for your practice.
Okay.
3 bells toll at intervals of 9, 12, 15 minutes. These are all in minutes respectively. If they, you can please note down the question also.
Yes.
If they start tolling is ringing. If they start tolling together, after what time will they next, this is next, will they next solve together? This is your question. Okay. Now three bells toll at intervals of, that means after how much, after some time interval they are tolling. Okay. One bell is tolling after 9 minutes, other one after 12 minutes, another one after 15 minutes. So if they start tolling together, after what time will they next toll together? So coincidentally, it happened that all the three bells tolled together. Okay. Now they are asking when will that incident come again, when they will toll again together.
After 180 minutes.
Yes. So what will you do in this case? You will first
LCM.
LCM of 12,
LCM
9,
of
12 and 15. Just find out
Yes.
the LCM of this. Okay. So we can go with 3, 3s are 3, 4s are 3,
3 for
5s.
the 3 5 and we
now,
can take 2 ma'am.
So LCM is what can you take?
2.
Where 2 you can, you know which is? This is 3 into 3. Now these are all different numbers. No?
Yes.
They have nothing in common now.
Okay ma'am. Yes ma'am.
Okay. 3 and 5 are prime and 4 is just alone. So this becomes 3 3 is 9, 9 4 is 36, 36 into 5 is how much? 30 is,
Ma'am, is it
the
180?
9 4 is 36 into 5 is 6 5 is 30, 15, 18. Okay, 180 minutes. That means after 180 minutes, they will toll together again.
Yes ma'am, I
So
got the same.
180 means after, okay, this
2
is just in minutes. In minutes only you have to give the answer because it is given in minutes, no? So you leave your answer in minutes. Okay, so next
Or
they
else
will
we
toll.
can, ma'am, we can write 180 minutes or 3 hours.
You can write it in hours. So they will next toll together after 180 minutes. Okay, or you can write it
Yes.
3 hours also. Right?
Yes ma'am.
So I hope you are understanding now. Is this, do you understand it? Where to find now HCF and
Yes,
LCM? Okay. And the language of the question is also very important because that's a trick. What the examiners normally do is that a trick. कि बच्चों को ऐसे ऐसे घुमा फिरा दो कि they are not able to find out. Let's see their smartness. Okay.
Yes ma'am.
So they try to trick you. Let's see how much the child is smart. Okay. So you also try to be, outsmart them. Okay.
Yes ma'am.
Okay. So please practice this, right? You want to take any more sum in this exercise?
No ma'am.
Just take any sum and we'll try it.
Yes ma'am, like they all are same methods.
All have same method. You can see this question also. Question number 2. 3 boys step off together from the same spot. Okay. See, 3 children are stepping together from the same spot. Okay. एक ही point से शुरू कर रहे हैं 3 boys. Their steps measure 63 centimeters, 70 centimeters, and 77 centimeters, respectively. What is the minimum distance each should cover so that all can cover the distance in complete steps? So what is the minimum distance?
Yes ma'am.
So what will you do in this?
LCM.
Minimum distance it will cover. So minimum distance so that all should cover in the complete steps. All should complete. किसी का step incomplete नहीं होना चाहिए. All should cover the distance in a complete step. So that is minimum word is written. So you will find the LCM in this. Right? Okay.
Yes.
Now, but the questions like this, यहाँ जैसे यहाँ traffic lights वाला था, and the one which I gave you, the tolling bells, no? In that case, it was a coincidentally happening thing. Okay. So the very first instant when it will toll again, the very first instant when the traffic lights will change together again. So that is the very first incident, the least in the least time span. So in those cases, you will see them. Okay, do
Yes,
you
ma'am.
understand it? Okay, so shall we wind up for today? Practice this, and still if you need more practice on these kind of sums, then we'll practice in the next class also. Okay,
Okay.
but otherwise if you feel confident about it, then we'll move on to next chapter. Okay, thank you
We'll
for
move to
today.
next
You must
chapter
check
now.
out the homework also, and
Okay, ma'am.
you must do your weekly test also.
Yes.
Okay, thank you. Thank you, children. Good
Thank you,
night.
ma'am. Bye, ma'am.
Bye. Good night.
Good night.